here at the University of Wisconsin Madison. I'll repeat that in just a little bit, but I'd like to welcome everybody and say that we'll allow another minute or two at most before we start. So again, thanks and welcome to everyone. Please take note, folks, if you don't mind, in the chat, please introduce yourself. And clearly, we welcome your comments and questions in the chat at any point. You'll be welcome to ask. We'll keep a queue. I think our conversations will be fairly brief, about 8 to 10 minutes. Each speaker will take 9 to 11 minutes, let's say. Each speaker will share a little bit about their intellectual trajectory with respect to this work. And then they'll describe the work that they've been doing with respect to this project and its how it's ramifying and how it will go forward following the conclusion of the iSchool project. Again, I'll just wait one more minute. Welcome everybody. Thanks for dropping your names in the chat. And we'll be happy to hear from you all. Well, good morning, everyone. My name is Alfonso Morales. I'm the Vilas Distinguished Achievement Professor here at the University of Wisconsin-Madison in the Department of Planning and Landscape Architecture. And I am very pleased to welcome you to this web presentation of work we've been doing along with colleagues at Case Western around AI tools for democratizing food networks across scales, national, regional, and local. Each of my colleagues will introduce themselves in a moment. Well, let me start, I guess, by saying my colleagues, Professor Dr Gao of the Department of Geography, and Michelle Miller of the Center for Integrated Agriculture Systems. We comprise the Wisconsin component of the iSchool project. I was the campus PI of this campus with respect to the iSchool project. And not joining us today, but whose work was also very important, is the work at Case Western University, led by Rahman Adeh, whose work I'll be describing towards the end of the presentation. So let me welcome all of you to the seminar. We'll take about 10 minutes each to describe the work we've been doing, and we will be happy to take your questions. Very well, let's get started. Song, would you please lead us off?
Yeah, thank you, Alfonso and Michelle. Can you see my slides advancing?
Yes.
Okay, great. Yeah, hi everyone. This is Song. My background is in Geographic Information System (GIS), and in the iCycle, my expertise is mainly on the geospatial AI, and then working with Alfonso, Michelle, and other colleagues about the AI for food system modeling. And as you know, that the food system contain a lot of network activities and resources, and getting food from farms to forks and beyond. This involve a lot of processes such as production, processing, distribution, consumption, etc. And one of the major challenges we found is actually in the food system, a lot of data sets, they occur at a different, spatial temporal scale. Oftentimes they have relative sparse data sets availability and also lacking the predictive tools about food access and modeling across different geographic scales, and also lacking, some of the data privacy for sharing. So this is why at iCycle, and our team developed various kind of AI and cyber infrastructure components and to address those challenges. So at the national scale, we build a food flow modeler. And at the local scale, we also build a food accessibility simulator. And you all see those details and the demos later. And we also had for the regional, we also had a modeling work about the food transportation and logistics. And finally, to bring the privacy data into the modeling framework, we also build the privacy preserving data sharing cyber infrastructure, enable the stakeholder to share the data and then to do the modeling without losing the privacy. So, and at the national scale, from the Department of Transportation, we have a well-known fleet analysis framework, the FAF zone level, which contains 132 food zones in the United States to capture the food flow between different places and cross different the 7 food categories in general, which is using the standard category of transport goods. So this is just the overview about the network characteristics. You can see there is some heterogeneity among those 7 different categories of foods. And this is why at the beginning we actually build a knowledge graph and to capture those different entities, different types and their relationships, and to analyze the national food network resilience. And as we know that if a region or place it has multiple supplier and also have a variety of commodity food types, or they have a maybe non-distant transportation, they will actually more resilient. And this is actually we build this framework and then such that we can analyze the food network resilience on the fly based on this geospatial knowledge graph. And then, if you remember in the earlier of the webinar, we have Dr. Dennis Karak. Actually, their team actually is one of the pioneers in this field, and they build multiple food flow models, and we essentially is a data-driven framework to estimate food flow between different like zone level or counties in US, and the model utilizing the machine learning network and production or other features, and but they're using the more classic ridge regression and to estimate food flow. So there are a lot of actually real world challenges such as missing feature or etc. So this is why our team build on this prior work from Dr. Dennis Karak. We build a deep learning model. So we build this scalable food flow model for over 9 million links across 3,000 US counties and using the graph neural networks, and especially to address the sparse data sparsity issue, and then we'll get more robust performance compared with more classic machine learning technique. So specifically, our model is actually the hurdle-based GNN architecture, which means that actually we build both link classification as well as the flow regression. The first module will determine whether there is existence of flow between 2 counties, and then the coupling module will determine how much, like in tons or in value, about the food flow for a certain category between 2 counties. And we also build several cyber infrastructure, such as software and also tools to enable those efficient data preparation and also processing. Yeah, this is just a quick overview, and essentially we build this, from cluster 132 zone level node features, and then also this county level edge features, and to build this model such that in the hurdle architecture we can do both classification and also the regression altogether. And in terms of evaluation, we have to determine whether the model perform well or not, and currently there is no like food category specific ground choosing data available at the county level. So this is why we only have the US sensors who are actually they only provided the aggregated level altogether. So we have to sum this overall comparison, although our model is at the county to county and food category specific level. And in this measure, the common part commuters, and this is a measure to quantify the spatial interaction. So this is good, especially for matrix, which is sparse, rather than using the R square. You will find some other issues about using R square. So this one is better to capture the spatial interaction when you comparing 2 sparse matrix. And this is a result map about the county level food flow modeling, and we actually compute in terms of the performance changes. without and with our node feature and edge enhancement, you can see the map actually the higher or the darker of the color, the better the performance, and the enhancement does improve the model performance. And more importantly, we will host this model as an AI service. So this is also one highlights in iCycle. We have a lot of AI services for different domains such as digital agriculture, animal ecology, and the food system. So this GN Food Flow is one of those, and this is standalone portal. And we also have released a new integrated AI service portal, and we hosted as you can see on the figure, we host multiple AI services, including this GN Food Flow at a national scale. And recently, we also built an important feature that is allow the user to run the simulation. For instance, you can see that if we change the origin like Los Angeles County, because this is a important exporter for the food security in the United States, and if we change such as maybe the employment sector or the agriculture production regarding the vegetable, soybean, corn, etc. And we can see, the what if to answer the what if question, what is the impact to other counties that link to the exporting Los Angeles County in California. So this the figure on the right showing you their potential changes if we reduce the vegetable, the whereas soybean and also corn, what would be the impact to the specific SATG food category, on the right side. Yeah, if later if I had time, I will share with you some of the demo on the website. But now I will continue move to my colleague, Michelle Miller.
Thanks, Don. I'll make mine quick too, so there's time to see your online demo. I think that's important for people to see.
Okay, sounds good.
So I've been working on a different aspect of this idea of applying AI in a democratic way. I've been working with practitioners to figure out how to develop actionable information given the data that they have available. And so the first thing I talk about with them is how other companies already are doing this project using AI in these ways so that they can understand better where their business opportunities are. And if you look at what's been going on at Amazon, you can read about their digital business ecosystems and how they use that to basically capture markets that could be also markets where local regional food is supplied. The other thing is, another thing that people are using is third-party logistics. 90% of Fortune 500 companies are using 3PL. So Amazon has an in-house capacity to do logistics and operations management, while most other companies are using a third-party logistics provider. Next slide. So how do we strengthen regional food, fresh food access? I think this is really important from both a nutritional as well as a business point of view. And really what we need are more information and material infrastructure to support collaboration, and that will lower costs for that fresh food and also create and support fair markets. And a lot of this rests on data and modeling. We can have shared cold chain resources, a cooperative structure, regional routes, even antitrust rules that really work, but those are all relying on data and modeling. Next slide. So one of the complications in logistics is this idea of a full truckload versus less than a full truckload. A full truckload is, could you go back a little bit? Thanks. A full truckload is one entire truck full of the same exact product going from one point to the next. That's really efficient and inexpensive. But as soon as you start dividing that truck up into multiple drops, you add a lot of cost into the system and a lot of complication. It creates a lot of different options then for the order of drops and driver conditions and several other parts of the supply chain. Next one. So in Europe, they know this, and they have a commitment to support chilled part load freight movements, whereas in the United States, we're really focused on getting those full reefers with all one product in it, going from one drop to the next. And so what this creates is an opportunity to make less than truckload deliveries more efficient. But it also requires optimizing a lot of variables. The dimensions of the products, the distance it's going, the weight, temperature, truck assets, fleet assets, driver availability, produce seasonality, customer constraints as well. When can they accept deliveries? When will they have someone to help? Do they have a dock? Do they not have a dock? How long does it take to unload? And then the differences between urban and rural distribution are quite great on a lot of those variables. Next slide. So how do regional food distributors optimize? I've talked to several of them across the country and in Europe, and these small regional food distributors are using the back of an envelope. They're doing it in their heads on the fly. They might have software, but it's often inadequate or expensive. And the net result is that it's costly, inefficient, and ineffective to apply AI tools in these instances. Next slide. So 80% of transportation costs are attributable to location within the distribution infrastructure. I was at a transportation conference in January and met a young man who had put together a poster looking at first mile optimization, where they had cold storage either at the farm level or at a central area for several farms to share. And what they found was that if they moved some of that distribution infrastructure to be shared infrastructure, they could improve first mile optimization of those routes by and realize a 9% operations cost reduction. So that's an example of how we would use AI and food systems information in an actionable way. Next slide. So the other problem is that we've got a last mile problem. That was first mile from farm to a distribution center. This is last mile from a distributor and their warehouse to a rural market. And there's an urban first delivery model that focuses on population and income density for logistics efficiencies. And that is not appropriate for rural grocers, rural institutions, rural communities, and it ends up costing them a lot more money to do it that way. So what we wanted to do is start building a logistics model that balances the shared risk along the supply chain with rural food access needs, and then thereby demonstrate the need for infrastructure subsidies to make this work better. Next slide. The first thing we discovered was that most businesses are using tabular data to manage their operations end to end. And this creates a lot of challenges in modeling because it's more difficult to use those data. So the first thing we had to do was build a tool to synthesize tabular logistics data for use with AI-powered optimization, specifically for small-scale food logistics planning. And I believe our developer for that is online with us today, Amit Vyas. Then we also created an AI tool to generate synthetic location and vehicle data for developers to do some of the modeling work. And we have just not even a beta version yet, but we're working on a beta version. And then we worked with the Wisconsin Food Hub Co-op to use their proprietary data to train models that were specific to the upper Midwest, because region matters. Every region has a very different system organization. We've also organized some faculty here on the Madison campus to assist with model development. And then we've held several stakeholder workshops on this topic. We have one coming up on May 28th in Waukesha. They were calling Tools of the Trade. I think there's one more slide. Oh, two more slides. So we're going to be doing a beta version of a prototype for the vehicle routing model. We've got field verification to do after that model's been developed using public and private data. We'll do a proof of concept for Wisconsin food systems based on infrastructure that's in development through the RFSI program. Some of you may be familiar with that program that added several infrastructure components to our food systems. And then we're hoping to have a vetted open source routing model that's specific for small to medium wholesale food businesses in the upper Midwest. Next slide. So we think that regional businesses can really benefit from this work. It will result in improved data organization. We'll have some regionally specific models. We'll be able to link systems. This is called enterprise resource planning in the biz. And we'll be able to then really support hub and spoke relationships with other independents working in this area. We think this will open up new wholesale markets at a scale that's appropriate for small regional businesses. And ideally, this won't need to depend on a data center or cloud computing. It won't be that large. It'll be something that the groups of businesses working together should be able to do on their own server. So that's it for me. Alfonso goes next.
Hey, well, good morning. Thank you very much, Song. Thank you very much, Michelle. Thank you very much, Regina, for helping us as well. I'm going to go ahead and replace the current share here with so that I can take you through my part of this presentation. I hope everybody can still see that. Can I get one nod, Song? Yes, thank you, Michelle. Okay. So in AI CI powered food systems, we have to integrate workflows. We have to recognize that businesses integrate across their multiple silos and both within a business as well as between businesses. So we have to recognize the importance of integrating workflows. And so the tools that Michelle and Song have discussed are very important tools that articulate with the tools I will discuss now. Let me begin by representing the very important work of our colleague Armand Ade, Case Western University, and his team were part of the iSchool Institute. We have worked with them to develop a privacy-preserving web portal for data integration and collaboration to the degree that the user chooses. They can discuss, they can reveal elements of their data and co-model the data together. This is an important tool to not just for analytics, but to proceed, as we say, at the speed of trust. And so we're very grateful to Armand and his team for doing this. This enables his tool is based on genomic privacy. That is his principal concern. And we have demonstrated the efficacy of the tool in a variety of settings. So again, we're grateful to Armand and his graduate students in work with us in developing this tool. So today, I want to talk a little bit about my work and the tools that my particular lab has developed here at Wisconsin. So just to give you a quick sense, I'm a social scientist and have been writing about marketplaces and food systems for virtually my entire 30-year career. And it's very important, I think, to point out that my work is both basic and applied. And its applied modality emphasizes community partnership. In effect, as Michelle has described in her work, community partners are the principal investigators of the work. Their expertise is highly valued and is used to drive the developments in the software. So my lab is the Kaufman Lab. I named it for a deceased colleague, and the initial software that was brought to iSchool was the farm2facts.org platform, farm2facts.org, which is a farmer's market, very granular level data. In the course of iSchool, we developed something called the Food Access Simulator, the FEAST, Food Equity Access Simulation Technology. And just to give you a sense of what that looks like, Let's see if I can navigate to it real quick. So you can see that we have a web page that describes what the feast is. It's an agent-based modeling tool and actionable across a variety of stakeholders. We have a demo here and tutorials, and all of this is part of the iSchool training catalog and the iSchool relationship with the high performance computing at TAC, the Texas Advanced Computing Center, where we utilize the Kubernetes pods called TAPIS at the TAC. So very important relationship there. And again, to emphasize the importance of relationships, generally speaking, in this space. The feast, though, does this sort of work, helps model, it helps interested users in local government and nonprofits model food security. So, and it was developed from understanding of local needs. My work on zoning for local food and various things over the years, and community engagement. Again, my work and work of colleagues at Ohio State. So we simulate food access, we generate scenarios that are used in decision support. And here on campus, we're developing an agentic AI curriculum in collaboration with the Data Science Institute to enable our student development team to become, in effect, software engineers, not simply developers of the software. So to give you a sense of what it looks like in its current iteration, we can go here to a map of the US and we can select a county. Let's select Brown County, Wisconsin, Brown County being the first paying client of the Feast software. And we can see that we can get a track map and a food access score that's developed from the literature on the subject, which our research is ongoing to develop this further. And we can go down to block group. We can even go down to buildings, although this is colored out right now. So we can get very granular here to looking at the food access score. We can also look at the food sites. We can look at grocery stores. We can look at supermarkets, and there's distinctions between these things. We can look at the farmers markets and the grocery stores. We can look at food retailers that accept SNAP benefits. We can also look at the floodplains. We can look at places that might be threatened by flooding. And the Brown County instance, they did in fact want a model that could adjust to emergency preparedness to enable decision support around emergency preparedness. We could get a dashboard and take a look at some of the different variables. And then, of course, we can go into scenario mode and we can step a model forward, adding or deleting food access modalities like supermarkets, or for instance, Feeding America can ask themselves, well, what happens if we locate a mobile market at this point? Or what happens if we aggregate food at this point to respond to an impending disaster? You can sort of have a sense of where hurricanes hit, for instance. So the model is, again, responsive, is developed through 2 years now of stakeholder meetings with folks in Ohio, Wisconsin, and Virginia. And our work is very much oriented to supporting the decisions of local government. So let me come back here to the food systems. Oops. So the slideshow mode. So the CI integration with colleagues across iSchool has enabled a much faster modeling process of the software. Our stakeholders can bring their own data. So the data that I just demonstrated about farmers markets and soon community gardens in Brown County, Wisconsin, demonstrate the ability for owners to do that. And if they require privacy, they can get privacy using the tools developed by our colleagues at Case Western. So their interest there in Brown County, as I pointed out, is scenario planning for emergency response as well as food as medicine. And you can look at some recent press in Planning magazine. So just to give some highlights, we've released a number of pieces of software. I'm grateful again to Song and colleagues across iSchool that have enabled us to be part of a national and even not international uh, network of colleagues interested in these problems, to which we're contributing this variety of tools. We've made a lot of presentations and engaged stakeholders in a variety of ways, not only here in the US, but elsewhere. And for those opportunities, we are also grateful and we're excited to have you all here with us. And again, let me just say, if you have questions, please put them in the chat because we'll be turning to your questions here in just a moment. And finally, I think we're going forward. We've got some interesting things that we're going to be doing with data and model commons, with the larger reference architecture that integrates these tools more thoroughly, with our interest in the backbone and community engagement contributions, and with tool development in a technical sense, right? Enabling users to use our tools real time as much as is conceivably possible. Instead of having to wait for models to run locally, we've got secure relationships with HPC at Texas, as I indicated, that enable folks to get answers when they need them, not how long it takes to produce them on their computer. So not to say that local isn't good, but sometimes using the high performance computers is very helpful. So folks, I just want to remind you all, I want to thank you all very much for attending this webinar. And we want you to know that there's a number of webinars, summaries and available at these web pages, as you can see here. We're grateful to a number of partners who have been supportive of this work over the years, and we look forward to whatever questions that you all have. I will stop the share right now and turn to your questions and concerns. Thank you again. Thank you very much for your attention. Who would like to start? Chat. Oh, anybody have any thoughts? Yeah, thank you very much for your attention. Please raise your hands in the air.
I was also wondering if we could see Song's demonstration.
Oh,
yes.
Yeah, I can do 3 minutes. Yeah. And then also allow people to think about questions. Yeah.
Kushank, if I read your name correctly, please hang on to that question or feel free to type it in the chat so that we make sure you're in the queue.
Yeah, thank you. Thank you, Alfonso and Michelle. This is great. And I just want to introduce you as I mentioned earlier, at Ethical, we host a lot of AI services at the cyber infrastructure. So this is the iSQL service portal, and then I will also put a link in the chat. Everyone can using your university credential to log in, and I will quickly go to the food flow portal we mentioned earlier. Also, I want to actually acknowledge, in the previous webinar we saw Dr. Kurang, his great work in Canada food flow. We also inspired by his avocado example. So here you can see we demonstrate the Franklin County OIO example, and using the meat and agriculture, because this is aggregated level, but you can see distinct food flow pattern. For example, for meat, and because of those temperature, transportation, special requirements, you will see more regional supply in terms of the meat. But if you switch to the agriculture products, the SCTG 03, actually you will see more distance, food flow or transportation, like from Washington, from California, etc. So this is why, if we launch the national, food flow portal, which will enable us to do the simulation, right? Running our AI model, and I'm going to show you, what would happen if we change the exporting, right? One of the largest exporting state in the U.S., California. So let's say if we want to change, maybe let's just change agriculture production, in California. Let's say maybe we have, as I mentioned earlier, I did some scenarios, less coins, maybe less vegetable, less soybean, hopefully not, but we have maybe more cattle with the improvement of conservation in California, etc. and we don't do anything for the destination from currently, and then we can run the model AI model on the fly. So run the one-to-one model, and then you will see, right? Immediately you can see how would the node feature changes would impact the destination country in terms of their food reduction, or you can see with more cow and in the farm, and we can see right more meat but less vegetable, etc. Yeah, this is just a demonstration. You can also run your own scenario. So the purpose is right. We can really run the AI on the fly to democratize the AI, which is one core theme at the ICICL. Yeah, that's all for me. Thank you.
Excellent, Song. Thank you very much.
Yeah,
Uh,
thank you.
so, Shank, you had your hand up first. Why don't you go ahead and go first, and then we'll go to Kamran. So, folks, please raise your hands. I will keep the queue.
Thank you so much, everyone, and also congratulations. Great work. I'm sorry I missed a part of the presentation. So, Song, um, if I missed something, if you already mentioned it, please feel free to correct me.
Yeah,
So, I
no
have a
problem.
few
Yeah.
questions. A few questions. Michelle, first, just on the long-term vision, and I guess that same question to Alfonso as well. Like the AI-based optimization for small enterprise you mentioned sounds really exciting, and I can see a lot of use cases for it. I'm actually working in close collaboration with Greater Vancouver Food Bank, where they basically try and source a lot of the food for the food bank from farms now to avoid food loss. It's all produce, but they often want to try and figure out how can we optimize and figure out how we can scale up. So that's one use case I could think of in Canada as well. But I was thinking, what is the long-term vision? Is it going to be reproducible, something that somebody can pick up and apply? Who's going to be running these models and for whom? And the same question goes for Feast as well. I see that, Kanzo, you mentioned that you had your first couple of paid clients. I'm guessing that's just the cities who are funding to run um, get the coverage on. And I'm sure that requires resources to build something like that, so comprehensive, for sure. But I'm just thinking again on the long-term vision part. For song, sorry, I have so many questions, but this is really exciting work, and I'm very passionate about it. So uh, that's why. Song, it sounds like I honestly didn't know so much about what's happening in the food flow world in the US. I was only aware about the Megan Corner's food flows work, and I found out recently that Sandy has done something as well. So I was just wondering, like, what's going on in this space? Maybe you mentioned it. Like, how do these differ different approaches? Now I have a sort of understanding difference between Sandy's and Megan Corners, but I just would love to hear more about that. And if there's any collaboration going on between you guys, or if there's a potential for bringing everybody working on food flows together in some conference or something to see what we can learn from each other. That's it. Thank you.
Yeah, thank you, Kushan. Yeah, who want to go first? Maybe follow the question. Michelle, Alfonso.
I can
Michelle,
go first. I'll go first.
me, and then okay.
Yeah, that sounds good. First of all, Kushank, I love your idea of a food flow conference. There are actually several agricultural economists in the country that are doing work in in food flow as well, but from a different set of data and slightly different approach. And I think it'd be really interesting to bring all these people together. I'm going to think about that, see if I can figure out how to get something like that funded. I would say, as far as who will run these models, our thought on the regional food models is that it would be run by the distributors. So we have a distribution co-op, the Wisconsin Food Hub Cooperative, that is already trying to buy as much local, so that first mile, and then also selling into smaller communities as well as some larger clients. And they've also started putting together and organizing what they're calling the Super Transport Co-op. So this would be the distribution hub would be the Wisconsin Food Hub Co-op, and then the spokes would go out to smaller distributors all across the state. We've seen this model work really well in France. They have a co-op, distribution co-op for locally produced products in France, and then they can also sell into larger kind of urban-based multi-tenant warehousing markets. So we think if they can do it in France, we can do it here. Go for it, Alfonso.
Okay, I will tag on. Kshank, I just put in the chat the link to farm2facts.org as well. That's mature software in its 2.x release that works with local foods, farmers markets, folks, from very granular level individual farmers up to coalitions of farmer market organizations. And the concerns there are ecosystem services tools, economic, social impacts. And so that is the model for Feast, right? It makes both softwares were developed with stakeholder interests in mind. Stakeholders will be expected to use the models. You're right, it costs some money to develop the model and to maintain the model in terms of an annual contract. But Farm2Facts has a Canadian instance. This started with the farmers markets of Nova Scotia 6, 7 years ago, and so 8 years ago maybe, and so likewise the Feast could have. I'd be happy to work with folks in Canada to adopt the Feast to Canadian needs or other countries' needs. The notion, of course, is that corporations use algorithms to make locational decisions. Nonprofits and local government can also use algorithms. Our purpose is to make algorithms available in effect to nonprofit organizations and local government organizations as a decision support system. The tools, our long-term vision is not just to develop the individual tools you see here, including our colleagues at Case Western and the privacy work, but also to see opportunities to integrate them. So, for instance, the Farm2Facts tool and the Feast tool can integrate in terms of local food security, local food access, by way of understanding the influence that farmers markets have in both the food security and the food entrepreneurship space, the Farm2X space, you might say, as well as food access questions more generally. Hopefully that makes sense. Hopefully you see the parallel the parallel activities that are directing our attention to the future vision.
Can I just ask a little follow-up before Song chimes in? Just so I'm just also thinking about, like, say, a food bank, which has very little resources. How can we mobilize these models for people who don't have any financial resources, or organizations that are small co-ops? Or so is there sort of a vision around that, and how do we basically make that happen?
Yes, I think the first part of that I think the first examples are coming. And what happens in local organizations is things like local philanthropies. The cost of the models are not as much as we might think that they might be. We're not talking about, for an instance of the Feast, we're not talking about hundreds of thousands of dollars, especially in the agentic situation where we can develop models based on where we have, in effect, what we call here in the US a stone soup approach. Whatever functionality is developed for one user is portable to another user. And so then the functionality becomes available. As the functionality grows, it becomes available to the users, which encourage more functionality, which encourages more users. And so the cost to nonprofit organizations, to any user, local government or otherwise, is not great. The city of Milwaukee, we presented to them last week, and they said, wow, we could get a philanthropist to probably pay for this, a model there in the range of maybe $30,000 to create for the Milwaukee County, a big place.
No, that's great. That's quite accessible for sure.
Yeah, hopefully that makes some sense to you. Now, of course, like with Farm2Facts, which has been an operation and has served hundreds of markets, economies of scale, right, can reduce costs. Song, why don't you go ahead and tag on, please?
Yeah, sure. Yeah. Thank you, Kushan, for the question. I think just add up, in terms of difference between our model and also Megan and Dennis, their model, I think is that, as you can see, we really focused on the scenario part. So similar to face at the local level for the national level, instead of run model for one time, we really hope to do the scenario simulation. So I feel that's one big difference. But definitely I also echo your source and Michelle's suggestion. Yeah, we should have one focused workshop or symposium about the food flow in the US. Yeah.
Thanks, Song, so much, and congratulations. That platform looks amazing, especially the simulation part.
Thank you. Yeah, this also made available because of the ISO. Yeah.
Thanks to iSchool. Yes.
Yeah.
Cameron, would you like to ask your question?
Hi, thank you. Thank you for the great presentation. I have a question for Michelle. I'm joining you from USDA headquarters, and I work in AMS, Agricultural Marketing Service, Local and Regional Food Division.
Wow.
And definitely AI is the big elephant in the room. And I'm happy that you're benefiting from how we can make the transportation efficient. But my question for you, Michelle, is who would be the user of the tool that you are developing for local and regional food producers? So one, who will be the user? And my second question is it possible to extend it to enable a small and mid-sized producer to be able to use that tool or something similar to decide about their transportation? Thank you.
Yeah. It would definitely be for the distribution companies, the small distribution companies. So our Wisconsin Food Hub Cooperative has, I don't know, maybe 20 routes, I'm guessing, less than 20 routes, I think. And they are selling product that they've picked up within probably a 200-mile radius, taking it to their warehouse and then shipping it out to various clients, including school districts, small grocers. They've got a few distribution connections with some of the big companies, like they do move some potatoes and onions to Kroger, for instance, and their warehouse in Wisconsin, or one of their warehouses in Wisconsin. But they also are connecting up with several smaller distributors. So there's a small food hub co-op in Iowa, in Northeast Iowa, and they're connected with them. There's another one in Minneapolis they're connected with. They're moving product to tribal communities across the state. We have 11 tribal drops every other week that they deliver to. So there are, they have several smaller clients that they are committed to serving. And because the distribution component is so inefficient, they really see a need for this kind of software to help them do a better job of making those relationships work. Did I answer your question?
Yeah, no,
Okay.
yeah, for sure. But my second question was how can we extend that to the small and mid-sized producers that they want to choose what method of distribution would be the best for them? Is there any way that we could extend it to that population?
Yeah, I think there is. I think the model itself will be kind of generic for the Upper Midwest. So depending on where you are, like if you're in Duluth Superior or you're in Northeast Iowa, it should still be usable for small businesses like that. And it's all open source. It's not, there's no the data is proprietary for the Food Hub Co-op, but the model itself will not be. So if you're a smaller business, you can plug your own data into the model and then use it for your own distribution management.
Okay, thank you.
Mm-hmm.
Thank you for the question, Kamran. We have time, folks, for a few other questions if folks have one, but while people are thinking about that, I'd just like to point out that as we discussed in our presentation, iSchool has training materials for virtually all the components across iSchool's 3 big use cases, as well as the various other AI CI components. And you can find in the chat our program manager and dear colleague, the brilliant as well as beautiful Nalima. So, Dr.
Thank you, Alfonso. So to answer your question, Kamran, I have put the link for the routing, of course, for whatever we have, for what Michelle just explained. So if there is any other questions or any other work that you would like, to be discussed, happy to talk to you about it. So just as a good material, as a starting point. Thank you.
Thank
Thank
you.
you, Alfonso, for the kind words.
You bet, Nalima. Boy, you're awesome. We are very fortunate here on all the campuses involved in iSchool. We've been very fortunate to enjoy the extremely effective support of Nalima and her team of developers and project management team. Really wonderful group. Okay, let's see. Do other folks have a thought, a question, a comment? Do you want to do some karaoke? Well, folks, I don't want to belabor us, but I want to express my gratitude. Michelle, would you like to say anything in closing?
No, I think the only thing is the center has been really excited by these webinars this last spring, and we're thinking about doing some more in the fall. So keep your eye open. We'll be sending out an email with more information about future webinars, I'm hoping. And they'll probably take place next fall or possibly next spring, depending on workload and people's availability. If there's a specific person that you'd like to hear from next time, please let us know that as well. If you have ideas for speakers.
Yeah, that's awesome. Thank you, Michelle. Song,
Yeah.
would you like to share anything?
No, I think I definitely really appreciate the interdisciplinary collaboration. Yeah, make this happen. Yeah, thank you everyone for joining us. Yeah.
Okay, well then I just want everybody here on the call and your colleagues to consider us for collaboration. Our tools are mature or maturing, and simply look for partnerships that help folks get things done. So we want very much for y'all to think of us as your partners in this, in the work that you're doing, at whatever scale it is. It can be very, very granular work in food system, in farming and food systems. It can be very macro in scale, with a concern of across national routing. And so we're thrilled for this opportunity. We're grateful to iSchool for the work we've been able to do. And we thank you all for the honor of your time. Okay.
Thank you. Bye.
See y'all later.
So much.
Thank you.